Hello and welcome to this Innovation Coffee Break. My name is Andre and I want to take you onto the journey towards the Linux-based simulation. Maybe at the beginning, let's have a look to the challenges the automotive companies are facing right now. So we see an increase of complexity of the ECU software. I recently read a paper where the number of lines of code have been estimated by 100 million lines of code, distributed over a large number of different ECUs. Also, new technologies are finding their way into our cars. Yeah, an example would be neural networks or even connectivity between different cars. This all leads to a change of development process, change of methods and tools within all these companies. Also, methods from other application areas are finding their way into the automotive domain, like continuous integration and continuous testing. So there, every newly developed piece of software is integrated into the whole system. It's compiled, it's linked, and already automatically tested. Also, parallel test execution becomes more and more important. Let's just imagine the training of neural nets. They require a lot of different simulations. What we can also observe is a heterogeneous IT landscape. So maybe one can divide these whole things into different application areas here. On the one hand, we have server and cloud applications. They require a large amount of automation, and they're typically executed on so-called cluster or clouds. Yeah? So it's not really interactive working place. On the other hand, we have the standard computers of the developers. So they want to test their own software, they want to have a simulation, do some changes, and all on their working place. And what we can see is that both application areas require platform independence. We see from a journey from Windows-based systems to Linux-based systems. And we need to meet these challenges. And one key technology here is software-in-the-loop testing, because software-in-the-loop testing provides you with the right amount of flexibility and scalability. So, what is ZIL testing? Let me briefly explain this to you. So just imagine you have a component of a car. Here you can see an engine. And attached to it, you might have ECUs. And in software-in-the-loop, you just strip away all of the hardware. What is left over is the software of the ECUs and the behavior model of the components of the car. Alone, these components don't really help you. So what you need is a simulator. There you can integrate all of these artifacts and you can configure the system and configure all the in and out ports. Once you have achieved such a simulation system, you can actually profit from a lot of advantages here. So one would be that you have a flexible simulation system. Yeah, you can start with a single virtual ECU, but you can extend the simulation system step by step until you have a whole network of virtual ECUs. You can integrate many different plant models to a full virtual vehicle. On the other hand, since it is only software, you can just distribute such a simulation on many different computers and do a parallel test execution. So let me just briefly give you an insight to VEOS. As you might imagine, a simulator alone is not enough. So what you need is a configuration part where you can actually configure the whole simulation system, and you need a build engine where all artifacts are compiled, are linked, and put together. Most important is the simulator itself. And we want to focus on the simulator here. Since PowerPoint is a little bit boring, we have prepared a demo for you. There you can see an interactive working place, or at least how it might look like. Let me give over to Stefan.
Thank you, Andre. I've prepared two PCs here for this demo, for the first part of the demo. And on the right-hand side, you can see a normal Windows PC with classic dSPACE software, motion desk, model desk, and VEOS player for simulation, to control the simulation. And on the left-hand side, you can see an Ubuntu system. And I will start with installing VEOS in this Ubuntu system. Okay. So let's see. Here's our dSPACE archive with the software, and I have to extract it. And afterwards, I can simply install it by calling the script. This will take some seconds, and afterwards, so this is done now, and afterwards we can start VEOS kernel. So that's it. So first part is done. We have installed the VEOS kernel here, and the system is running. So next, we will start loading a simulation system into this VEOS kernel, and we will start doing this in the terminal again on the left-hand side. I will open another bash here, and we can simply load it with VEOS sim load and VEOS ASM traffic example, and that's it. Okay. Okay. Next, I will switch to the Windows PC. And here, as I said before, here you can see the VEOS player. And now I will load the same simulation system from the VEOS into the VEOS player. And of course, I have to connect to my Linux system where the VEOS kernel is running on. And so this was it. And now I can start simulation. And simulation system or simulation is running on the Linux host now. Next, I can download the scenario with traffic sample. Here I simply click on download all in Model Desk, and this will download the road and the scene. And of course, this takes some time. This takes some seconds here. And afterwards, I can also attach Motion Desk. So now it is ready. Simulation is running. And I can connect here our Motion Desk, go online. And what I forgot, of course, is I haven't reset this system, and I have to start. And now simulation is running. So now simulation is running, and you can see the output here in Motion Desk on the Windows PC, and the actual simulation is running on our Linux system here. So, and that was the first part of the demo. Back to you, André.
So, thank you, Stefan. So what we could see here is how an interactive working place could look like. But we all know that scaled simulation is very important. And there's a lot more than just simulation. We all know that. You need a preparation of simulation systems. You need to create tests. You need to simulate and all these analysis stuff. But again, we want to focus on the simulation here. So in order to massively scale up the simulation system, you probably start with a single simulation. And one can actually put this simulation into a container. So in this example, we use a Docker container. So you put the simulation system, the simulator, all dependencies into this container, and then you can execute it. So what do? You just hand it over to a management software. In this case, we use Kubernetes here. And then Kubernetes can actually distribute it among many different computation nodes. And there you can perform large-scale testing, for example, parameter variation, and so on. And again, we have prepared a little demo for you. So let me give over to Stefan again.
Thank you, André. Let's start with the second part of this demonstration, and we will create a Docker container here. And again, we will take the VEOS archive with the setup, and we have a Docker file here to build an image, a Docker image. And now we simply run docker build, and then we have to wait some time because he has to set up or install all the software and the dependencies. And yeah, afterwards we can start it in, or take the image and load it into our Kubernetes system. Now we have built the Docker image, and I've also prepared a Kubernetes configuration file here. And here you can see VEOS service configuration as well as deployment for one container. That is the image we have just built. And I will copy everything. And then I can open the Kubernetes dashboard. And right now nothing is running on this system. And I can create a new resource here, adding this configuration, upload, and now we have to wait some seconds to boot the system, and now everything is running. And I can look into the pod and show the log file, and here you can see VEOS simulator is running now inside the Kubernetes cluster. And now I can switch back to the Windows PC. And here again, you have the VEOS player, and it's exactly the same simulation system that we have simulated before. But now I will load it to this Kubernetes pod here. And I just load it, and you can see it is running. And here on the right-hand side, on the bottom, you can see now the simulation is really running within this Kubernetes pod. So now you have seen we have brought this simulation system into our Kubernetes cluster. It is running, it is simulating, and yeah, that's it. Back to you, André.
Thank you, Stefan. So let me wrap up this session here. VEOS becomes platform independent, but the journey is far from over. What you could see is that your simulator is able to simulate on Windows PCs, but also on Linux PCs here. But the journey is far from over. There are further developments which actually improve the whole simulation experience. So with that, VEOS becomes a key technology, a solution for you when you are going for integration testing, for continuous integration, continuous testing, and all those things. We have a solution for server and cloud-based applications and for interactive testing. Thanks for watching.